Morning, everyone. Hi, I'm Isaac from Pulumi. We're going to get started with this webinar, Sharing and Reusing Infrastructure with JFrog and Pulumi in just a few minutes. And while we wait for our presenters and attendees to get settled, I have a few poll questions to run by you and see sort of what your familiarity is with Pulumi and with Artifactory. So here's number one. Okay, so it looks like most people on the call here are just kind of starting out using Artifactory or haven't started yet and are curious to learn more. It's good to hear. So hopefully people will learn a lot and can get started right after this session, and we'll have some helpful links for you afterwards. So the next question is, how familiar are you with Pulumi? All right, so it looks like there's quite a few people who are also fairly new to Pulumi as well as a few people who are using Pulumi in production. That's good to see as well. So finally, I have one last question for you, which is, if you are using Pulumi, what is your favorite Pulumi superpower? All right, it looks like people are pretty interested in all the new features. That's good to see, with testing being the most popular. Okay, with that, I am going to turn things over to Dan and Melissa to tell you more about how to use Pulumi and Artifactory together to share infrastructure.
Welcome to today's webinar, Sharing and Reusing Infrastructure. We're going to learn how to build, share, and consume cloud components with Pulumi. My name is Dan Hernandez. I'm a customer engineer with Pulumi. I work and live out of upstate New York, and I've been working in the infrastructure as code and cloud space over the last 5 years. I've consulted with a few teams and organizations on their infrastructure as code strategies and cloud patterns in that time. So I'm very excited about today's topic.
And my name is Melissa McKay. I'm a developer advocate for JFrog. I've been a developer and a software engineer for over 20 years. And over that time, I've gained quite a bit of experience in a number of different languages, technologies, and tools of the trade. I've become especially interested in tools, frameworks, and technologies that make development more efficient and software more reliable, which is why I'm in the position I'm in today. I'm excited to demonstrate with Dan today how to share Pulumi packages. I was recently introduced to Pulumi and what it can do for you with regard to managing your cloud infrastructure. And it's a great tool to have in your toolbox.
Today, we're going to be talking about how you can build, share and use cloud architecture patterns to improve your team and organization's effectiveness. We'll start by talking a little bit about cloud components, and then we'll introduce Pulumi with a short demo, and then demonstrate how to build a cloud component from scratch with a simple example. From there, we'll demo a more interesting cloud component that we put together for you and show you how to share and consume that component using Artifactory. I want to take 2 minutes to talk about why you build cloud components. I'll share 3 primary reasons, and I'm sure there are more. First, to improve the dryness of your code base, meaning do not repeat yourself, and to reduce the amount of code that's rewritten. This goes team-wide and organization-wide. It's very likely many teams are using the same patterns and even using the same pattern multiple times on the same project. Second, simplify the experience working with cloud and infrastructure as code. The cloud is complex, but increasingly organizations are encouraging shared ownership of infrastructure. So many teams and individuals may not have deep cloud expertise or desire to understand implementation details of infrastructure, but components allow them to take that first step. Lastly, and important for many large organizations, is to enforce best practices. In regulated industries and otherwise, there's often a desire to standardize on compliant architectures, which enable higher levels of productivity for development, operations, and the security team. And you're probably curious how Pulumi and Artifactory and JFrog help with this. So I'll get into the Pulumi side, and then I'll hand it off to Melissa to talk a little bit about JFrog. So Pulumi, to kind of start talking about Pulumi, Pulumi is a next generation infrastructure as code toolset. And its goal is to improve the effectiveness of working with the cloud. And it really enables collaboration between all teams focused on developing and delivering cloud software. So with Pulumi, development, operations, and security can all work together with speed and safety. And the Pulumi product itself has 2 main parts. The SDK, software development kit, includes a command line tool, software packages for all supported languages, and plugins for all major clouds and many SaaS products. And the SaaS service, which provides an out-of-the-box infrastructure as code management plane that is useful for teams that want a high level of visibility and want to focus on delivering software and not developing and maintaining important features like state locking, management, teams, role-based access control, auditing, and SSO. You also get access to additional features like policy as code. And one of the major Pulumi differentiators is the use of real programming languages to author infrastructure. This means that it's easier to get started since all familiar concepts and programming languages are available. So concepts like for loops, if statements, and standard package management and versioning. This is also great because any of the skills developed while using programming languages through Pulumi are applicable broadly and will set your team up for success. Another important differentiator is deep support across many architectures, such as virtualization, containers, Kubernetes, and serverless. Pulumi ultimately makes working with any architecture and multiple architectures at the same time really simple, and is there to grow and evolve with you as you adopt new patterns and technologies. So that's a high-level overview of Pulumi. I'm going to run through a quick demo and get into the topic of today, building and sharing cloud components. And as you can see here, Pulumi does support a number of different tools and many familiar languages. So what I'm going to show is the creation of a new Pulumi project, how you can author cloud resources, and the workflow to manage resource deployments using Pulumi. After that, I'll show you how to create a cloud component from scratch using Pulumi. Then Melissa will take over and share a more interesting example that we've put together and how to save, share, and consume it from a central location in Artifactory. To create a Pulumi project, we first need to create an empty directory. Then we'll run the Pulumi new command. You can see we have a number of templates available for supported languages and major clouds. For today's demo, we're going to use the AWS and TypeScript template, but everything we'll show can be done just as easily with other languages and clouds. We'll provide a project name and go with the default. We'll provide a description and go with the default. And we'll provide a stack name and also go with the defaults. But before I do that, I want to take a quick moment to talk about stacks. So a stack is an instance of a project. You can have multiple stacks for a single project, and they will all use the same code and are differentiated based on their config. So our users most commonly use stacks for different environments, such as dev, staging, and production. And when you create a project, you need to create the first stack, and that's what we're doing here with the dev stack. Since this is an AWS project, Pulumi knows to ask what region we want to deploy into. I'm in upstate New York, so the default of US East 1 is actually the closest region for me, so I'll use that. Now, what Pulumi is doing is copying over the template and installing all of the required packages for me. Note, today, I'm actually connected to a private instance in proxy of NPM that Melissa set up in Artifactory, but we'll talk a little bit more about that later. Now, that this is done, my project and dev stack are ready. But before we deploy this, let's take a closer look at what files Pulumi has generated for us. So on the left here, you can see there are a number of different files and folders. We have two Pulumi config files, an index.ts, where our Pulumi code is written, and the rest are configuration for TypeScript, Node, and Git. We're going to focus most of our energy in the index.ts file, but I will note that the pulumi.dev.yaml file is our config file for our dev stack that we initially created for this project. So any config values that are unique to this independent stack can be stored here and then used inside of a Pulumi program. So that said, let's take a look at our index.ts file. So at the top, we have packages that we've imported. In the middle, we have a declaration of a Pulumi resource. And at the end, we have stack exports. So for the packages, you can see we have 3 different packages by default in this template. The first is the Pulumi package. And you can think of this as a base package for all Pulumi programs and a place to look for useful infrastructure as code functionality. So one example of this is reading config from the Pulumi stack config file that I just showed you. And the code I just wrote will actually retrieve the value to be used in our program from our dev stack here. And there's a lot of power here and a lot more features, but I won't get into it much further than that. So the next package is the AWS package. This includes the entire landscape of resources for AWS. You can see our single AWS S3 bucket is using this AWS package. I could also create more resources here. So through this, you'll notice I'm getting code completion and docs right in the IDE. So if you want to know what parameters I need to include, you could dig right into the code, and you know that your code is well formed before you even try and deploy it. This is one of the superpowers, so to speak, of Pulumi, is being able to have a really great developer experience and being able to understand the code that you're writing and have a very fast feedback loop on this. So that's the AWS package. It's really just the full landscape of AWS. This could also be for GCP or Azure or Kubernetes or Datadog or New Relic or any of the providers that we have available, you can access here. And this last package is a special package. And that's because it provides an abstraction on top of the base AWS package. It's open source and authored by Pulumi's engineers, and it really serves as a great AWS starter and an example of how to build a Pulumi component itself. So let me show you an example of one of the resources that has been built in AWSX. So this resource represents a number of underlying AWS resources that use best practices. A VPC, of course, but also subnets, route tables, route table associations, really everything you would need for an AWS network. And you can see how this can provide a much better experience using the cloud than base AWS resources, right? So folks who may not have a bunch of experience working with AWS or any various cloud, this is a great opportunity for them to use best practices and architectures that have been put together by people who have that experience. So that's the AWS X package. So now I think we've got a pretty good gist of how resources work through the few examples I've shown. But I want to discuss, one common misconception that we have about Pulumi as it relates to this. The common misconception is that Pulumi is an imperative tool, meaning it runs like a script. So if you were to run Pulumi multiple times, it would create duplicates of the same resources. It turns out this isn't how Pulumi works. Pulumi is a bit smarter. It uses a declarative model and engine, meaning what you declare in a Pulumi program is the source of truth, and the engine will do what's necessary to get your deployment into that state. So let's go ahead and run this using the Pulumi CLI to get a better idea of what I'm talking about. And to run a Pulumi program, we need to use the Pulumi up command. Now, what Pulumi is doing is running the program to see what resources I've declared and any associations between those resources. Then it's going to look for the state of my stack previous to this run. And in this case, this is the first run, so Pulumi knows to create the S3 bucket resource. And it gives us an opportunity to review any proposed change and decide if we want to continue with that update. In this case, it looks like Pulumi is going to do what I expect, so I'll continue to do the update. So what Pulumi just did there is made what I declared a reality. It's really taking a look at the desired state I defined in my code and in my program and executing the right set of steps to turn the current state of my deployment into the desired state. That's what declarative infrastructure means. Declare the desired state, and the engine will put together the set of steps needed to make that declaration a reality. So in this case, if I wanted to update the bucket name, we could do that, and Pulumi would know to delete and recreate the bucket and not just create another bucket. And as expected, Pulumi has decided it needs to create a new bucket and delete the old bucket to get to my desired state, since buckets can't be renamed. And again, I have an opportunity to see what's changing before I make a change. So this allows me to safely make changes to my infrastructure and to my application. So that's the Pulumi SDK in a nutshell. It's important to note I'm also using the Pulumi SaaS service, and that's running in the background. And it would be great to kind of walk through the value there, but for the sake of time, I'm going to go into describing how to properly author a Pulumi component for yourself. So what we're going to do this is we're going to wrap our S3 bucket in a Pulumi component. And I'll go ahead and cancel out of this change here. So we're going to wrap our component in a class. We're going to call this class a private bucket, because we're going to make this a private bucket implementation here. And it's going to extend the Pulumi component resource class. So this is available in the SDK. And what we need to do next is implement the constructor. And the first parameter we're going to definitely need is a name for our component resource. This is going to be the name that's provided by the user when they create a new version of this. And the first thing we're going to need to do is call the base constructor. And to do that, we're going to run super, and we're going to pass in the name. But we also need to include one other piece of information. And this is going to be the package name. And this essentially organizes this Pulumi component with other Pulumi components. And it's a required format. So we'll start with Platicorp, AWS, and we'll call this the same as our resource itself. So this is what's going to actually be stored in the state file, and this is how Pulumi is going to organize instantiations of this component. All right. And with that, we can go on to declaring our resources. So we can move this bucket into our constructor, which is the best practice way to do this. You can also create functions to call in the constructor, but the important part is that anything that you want to bring up needs to happen in the constructor. So we'll add the bucket here. And two things need to happen with any resource that you add to a component. The first thing you need to do is incorporate the name that's passed in through the constructor into the name of any resource. And this is because when the component is instantiated multiple times, you want it to be unique. And if it was the same name here for multiple components, Pulumi would run into itself. So we're going to include the name here. And I'm just going to add a postfix of buckets. In addition to this, we're going to use the canned ACL, and we're going to set this to private. This is what's going to make this bucket different from other buckets. Is I'm setting a default with it so that anybody who instantiates this will get a private bucket. And the last piece here that's important is to set the parent to this component, right? And this is going to make sure that the output when you run Pulumi up is structured properly, and also that any associations in the state are set up properly as well. And also in addition to that, if there's any special providers that are passed through, this will make sure that these child resources get the same providers. So now that we have that set up, I'm just going to clean it up and make it a little bit easier to read here. So we're going to remove this export statement. And one more thing that we're going to add is an output, right? So we've declared our resource, but we want likely to get some output from this. We want to see certain values, and the way that we can do this with Pulumi is by setting some read-only variables on the component itself. So in this case, I'm going to create a name ACL variable, and it's going to be of type Pulumi.output with type string. So if you're not familiar with Pulumi outputs, that's okay. We won't get into it now, but you can think of outputs as a way for Pulumi to properly manage the asynchronous nature of creating multiple resources, such that it can cascade values, because at any given time, not all values are available. And I'll leave it at that. In addition to this, what we're going to want to do is, after we've declared any resources towards the end of our component here, we're going to set this name ACL equal to the, and we'll use interpolation here, the bucket name, which is denoted by bucket and bucket, and we'll include the ACL as well. Oh, one thing I missed here. We're going to need to use the Pulumi interpolate function, because this is is what's going to create that output, because at any given time, it may not, the Pulumi bucket may not be available. So just know that. And lastly, what we need to do is register the outputs. So we need to use the register outputs function, and we're going to register name ACL, and we're going to set the value to name ACL. So this will, again, make it such that this value exists in the Pulumi service itself and is tracked in the state file. I will delete this, and let's go ahead and use this component now. And let's export a variable here. And we'll update this to name ACL. So we'll be able to see that value when we run Pulumi up next. And what we should see is Pulumi's going to delete the old bucket that we had, as you can see in this line right here. And it's going to create a new Platycorp AWS private bucket. So this is where this name comes into play. And this is how it's organized. And within that, we'll get the AWS S3 bucket that we've defined here as well. And this is where that parent variable is important, because if we didn't include this, it would actually sit next to it, similar to how this is. So it's really important to make sure we include the parent variable there. And let's go ahead and run it. Great. And we can see in the output, our name ACL has our private bucket name, and the ACL is indeed private. So what if I wanted to create a public read component? Well, I could copy this code over and create a public read bucket, but what I think might be more interesting and likely more useful is being able to provide inputs into my component. So the way you can do this is, of course, by using the constructor. So in this case, what I'm going to do is call for a ACL. And I'm going to make this of type string for now. And what we can do is pass this value down into our resource here. So instead of having private, we can set this up to be ACL like this. And I'll take this one step further and declare a type. And this is a union type in TypeScript, but this is essentially the same thing as an enum in many other languages. And I'm gonna call this canned ACL. This is gonna be set to private, or another option is to set it to public read. So again, this is just another reason why using programming languages is really useful. You can use this basic function of TypeScript to ensure that the inputs that you're taking in are formed properly. So I'll update this from a string to and ACL. And then you'll notice that we need to update our private bucket here. And what I'll do is change this to private. And let's go ahead and create a public read bucket. And we can probably actually rename this, right? Let's just make it a bucket. It's not just a private bucket now. And we'll update the export so we get the second one here. All right, let's run Pulumi up. So that is a really simple example on how to build a Pulumi component, but it's not really a very interesting real world example. So let me show you a closer to real world example that Melissa and I have put together. So the example that we have is currently stored in GitHub, and it's a component that will deploy a Docker web application to AWS. And this will include creating an ECR registry. It will build the Docker image and push it. It will bring up the ECS cluster. It'll create a task definition. It's going to create, I think, well over 30 resources, because it is taking advantage of the AWS X package under the hood as well. So we've got 2 packages that we're taking advantage of. And really what will happen is a developer can provide a path with a Docker file, and Pulumi will send back a front-end URL. So it's a really simple experience for the consumer of this, where they'll just have to include a single line of Pulumi code, and they'll get a bunch of different resources created for them. So let me hand it over to Melissa, and she'll show us how to share and manage this component with some great features in Artifactory and JFrog, and then I'll show this component running right after.
Thank you, Dan. I'll go ahead and take it from here and talk to you a little bit about Artifactory and where we come into play here. I want to explain to you what that product is for those of you that aren't familiar with it. Artifactory has evolved quite a bit over the years. It's difficult to talk about it by itself without talking about the JFrog platform. The latest release of Artifactory is actually the basis for the JFrog platform, which was released at the end of February this year. Prior to that, each JFrog product was managed separately with separate UIs and separate behind-the-scenes administration. So the JFrog platform is the result of a thoughtful approach and years of effort to make the experience of the product suite as seamless as possible. I will be showing you a demo today of what it looks like. You'll be able to see what I'm talking about there. All of the administration, configuration, and access permissions and stuff is now all centralized. The end result with the release of version 7 is the industry's first hybrid end-to-end universal DevOps platform. It's hybrid because we offer both on-premise and cloud solutions, or a mix if that's your need. It's end-to-end because our product suite does have the potential to manage your software development workflows all the way from source control to distribution. It's universal, not only supports major package managers and integrates with leading CI servers and other DevOps tools that you already have. You can also scale your environment through clustering as your business grows. So Artifactory, let's back up a little bit. It is a binary repository manager. And why would you need that? What is it for? Basically, it's not just for the storage and management of Pulumi packages, for example, but for anything else your developers require, from remote sources or anything you need to manage that is built internally. These are all of the files, artifacts, packages that you consume in your builds or that you need in order to get a release out. Artifactory provides a single source of record for all of the artifacts that you produce and consume. It gives you a bill of materials for your builds so they can be reproduced with exact required versions. That really helps speed up troubleshooting of broken builds due to version changes. Another advantage that Artifactory provides is a cache of third-party packages to keep you from suffering from broken builds because a package is temporarily unavailable from the source, it's moved, it's been renamed, or even just flat out deleted. Another interesting thing about Artifactory that impressed me was the checksum-based storage. So Artifactory is composed of repositories. This is what we'll focus on most today because this is where your Pulumi packages will go. There's three main ones. There's local repos. These are your builds, your binaries, everything that you create internally, things that you produce. They come from internal Maven builds, Docker images, Helm charts, NPM builds, which we'll see today, or other generic files. Remote repos are third-party dependency stores that you rely on for your builds. These can be either from other teams or from other public central repositories. And some examples of that is like JCenter, Docker Hub, NPM org, PyPI, NuGet, all of those. Each remote repository is set up with a remote URL that you want to be able to pull dependencies from. And anytime that you have an internal build that references your remote repository, Artifactory will check the local cache first to see if it already exists before reaching out to pull anything. The last one is virtual repositories. This is where the magic happens for developers. These are repositories that are actually combinations of local and remote repositories. It's an aggregate of everything together. The advantage of using virtual repos is that your developers can use a single URL to both get third-party dependencies and place your internal artifacts into your local repositories. So one of the things that we see a lot of that I want to touch on is that we see a lot of companies use one massive local repository for their usage depending on the package type. Having a single repository like this that just grows over time can cause some headaches when it comes time to replicate to another site or move to a hybrid or SaaS solution. Having everything lumped together like this can also make it difficult to manage what can be cleaned up and really causes you to lose some flexibility when you want to make changes. And now you have to figure out how to move a 10 terabyte array. So another issue that we see a lot is the lack of use of virtual repositories. So I'll show you today how those work and how you can make them work for you. So this slide describes repository naming. It's a good practice suggestion on how to name your repositories. There's a 4-part naming scheme used here. The first part is either the name of a team or a product. In this case, I used app. The second part is the package type. The third is the maturity, as in which stage of development lifecycle does it reflect. This is the important part that I want to highlight here, because by organizing artifacts this way, a product team now has the flexibility of promoting an artifact through the software development lifecycle. For example, let's say you have a Pulumi package component that you would like to share. Once it's been through QA and it's ready to be promoted to staging, that component artifact can actually be removed from the QA repository and put into the staging repository so that it's available. This method of promotion also allows you to set up permission models based on the environment these repositories should be available for, rather than solely around specific users or teams. A good example of that is if a production environment only has access to repositories that are specific to production, and artifacts are only promoted to a production environment when they've passed certain quality gates, then you can avoid deploying artifacts accidentally too soon. The last part of the naming scheme is a physical topology locator. In this case, I used local. If these were managing replicated artifacts somewhere else, I'd give them a different designation, like Denver or New York, something like that. All right, so now I'd want to jump in and actually show you some of Artifactory here. Oops. All right, so I've launched a trial version of Artifactory. This is run in the cloud, really simple to set up and use. And this is pretty fresh, other than you can see we already have some packages in here from the builds that Dan has done. Right away over on the left, you see the navigation here. This is right here under Artifactory and Artifacts. This is the typical view that most people are familiar with for Artifactory. You can see that we have a number of different repos here available. I'm going to skip over to the configuration. This is where repositories are actually created, and this is where they're listed. It's pretty easy to tell, you know, what's local, remote, virtual, all of that stuff. The local repositories that we have set up here, you can see we have this Pulumi npm dev local, prod local, QA local, staging local. It's following the same naming guidelines that we just talked about. We have some remote repositories set up. I'm gonna look at this npm one since this is the type of package that we'll be working with today. Setting up the remote repository just entails putting in the URL of where you want to be able to get your third-party resources from. Now onto virtual. These are the fun repositories, the aggregates. I'm going to look at this one, the Pulumi npm repository. This has been set up to include all of our local repositories for this project, as well as the remote repository. And something to note here, when you set up a virtual repository, you can select any number of these repositories. They all need to be the same package type, but your dependencies will be resolved in the order of these repositories. So in this case, we are going to resolve any dependencies from local repositories first before resolving from a remote repository. All right, let's go ahead and try and create. Let me go back here and bring up my. We're going to create a package, and I'm actually going to use the shared component that Dan showed you earlier. We will create a package out of it. I'll go ahead and publish it, and then you'll be able to see how that's consumed. So I'm going to set up a template just to start with. I'll just call it JFrog Pulumi components. Okay, now this is the important part. This is an NPM project. Before I do anything, I want to go ahead and set my registry appropriately and log into the registry. By doing this, it will pull in any third-party dependencies that I've asked for when I build this project. It will pull them into Artifactory so that I won't have to ask, they won't come in remotely anymore. And then anything that I produce from this build and I publish will go into the appropriate place. Since I work with a lot of different packages, it's easy to forget how to set up all of these, and I want to show you this really convenient place where you can find all of this information again. If you pick this virtual repository example and click on this Set Me Up button, it gives you all of the information that you need to set up your registry, how to log in, how to authenticate, how to deploy and publish, how to resolve your packages. So what I'm going to do today is go ahead and set up my registry. And then I'm going to log into it. And with this, you just use your credentials that you have for Artifactory. In this case, I'm an admin. Add my email address. Okay, so now I'm logged in. Now I'm ready to go ahead and start this template. So start with Pulumi new. I'm going to choose TypeScript since we're using NPM. I'll keep this project name, project description, leave it the same. I'll just keep it a dev stack. Keep the region. This is just something for me to start with. Right now, this is pulling in all of the third-party dependencies that we need and pulling them into Artifactory. All right, cool. So if I look at my file structure here, got a bunch of stuff to start working with. Dan has shared a GitHub repository with me with this Docker web app component that he started. I want to take this component and I actually want to fix this up and share this so that other developers can pull it in. Now, what I'm doing here is kind of manually on my local box. Of course, you would want to set up your own GitHub repository and manage versioning and stuff like that there. To save time, I'm just doing this locally. So the first thing I edit is the index in order to get my component. The other thing I want to edit is my package.json. Here I want to not only provide a version, but I also want to provide the repository that we'll be pushing to. Okay, I'm going to fix up this version. Oops. Set it to 1.0.0 since this is our first one. Note we have our main file here. We've got our scripts for when we want to, what we want to do when we build. Now we're ready to go ahead and build this. And lastly, since we already have our repository set up where we're going to be pushing to, we can go ahead and publish this. All right, now let's head back to Artifactory here. I want to show you something really quick in the virtual repository that we have set up. So in this Pulumi NPM repository, there is a setting down here called default deployment repository. So when I did a publish, this is the actual repository where I expect my internal artifact to end up. So let's go check and see if it's there. Go to Artifactory, go to Artifacts. This is my Pulumi npm dev loco, and here it is. Here is my package here and all of the artifacts that are related. So at this point, any developer that is using the virtual repository URL should be able to pull this component and use it as long as they have access to this Artifactory instance. So at this point, I'm going to pass it back to Dan, and he can show you what that looks like.
All right, thanks, Melissa. That was a really great demo on Artifactory. And while you did that, I actually had enough time to refactor my code and actually run it. So this is my new code. I've moved my bucket into a separate file, and I've also added and incorporated the Docker web app component. And if we want to take a look at the config on my machine, you can see that it's set up pointing to the Artifactory npm repository. So it was really easy for me to update my package JSON and pull down this component and use it in my application. And again, for this application, it's really, really cool because what I've provided is simply a Docker file and a web app, a very simple web app in this case. And Pulumi has managed deploying that to AWS, and it's created an ECS cluster, a VPC, Fargate task definition, a load balancer, everything that I would need to deploy a web application in AWS. And let me actually run Pulumi up one more time, and we'll be able to get the front end URL from this. Awesome. So I'll go ahead and actually grab this URL. And we can see built with a component and made by us. As you can see, just within a matter of 5 minutes, I was able to get up and running using Pulumi and Artifactory. And Pulumi and Artifactory can be used together in many different use cases. So networking is a really common one we see. We see Kubernetes clusters, ECS clusters. Anytime that there's a complex use case and an architecture that you want to reuse, you can do that using Pulumi. So it's really anything. And a quick takeaway here is really just, what we did was build a cloud component using Pulumi, and you learned how to share and consume that component with Artifactory. And we're ready for Q&A. So if anybody has any questions, please feel free to ask in the question box, and we'll get started on those.
Thanks, everyone. Yeah, so as Dan said, we are open for questions. So please use the question box, and I will help moderate those questions and direct them to Dan and Melissa as appropriate. I think question number one is for Dan. So is there a limit to the number of resources that can go into a component?
No, that's a great question. And the simple answer is no. It can be any number of resources. There isn't necessarily any limit.
Okay. Question number two, is it possible to deploy to multiple clouds using Pulumi?
Also, that's another great question, and it's a really interesting use case actually for building cloud components with Pulumi. I showed an example where you deployed to AWS, but I could have additionally included an option to deploy to GCP or Azure and have taken in a config variable to decide where to deploy it. And I guess a little history lesson, Pulumi, we actually tried to initially create some of these types of multi-cloud packages, but what we found is there are so many different use cases, and it's so nuanced that we just want to enable the community and folks to be able to create options of their own for this. So yes, you can absolutely create components using many clouds, and we highly encourage it.
And this one is for Melissa. Let's see, what cloud providers does Artifactory support?
That's a good question. We support AWS, Google Cloud Platform, and Microsoft Azure. I just want to note too that we also have hybrid on-prem cloud installations if that's needed. You can independently choose to install Artifactory in the cloud environment of your choice, but we also have cloud plans available that are JFrog managed, and this gives you the advantage of always being on the latest version because JFrog will handle all of those upgrades for you.
Okay. And then one more question for you, Melissa. What type of training or certification is available for Artifactory?
We do have certification. I can post a link in our chat for that. There's a link on our website for that. There's on that page too, there is links to JFrog Academy, which is like a video-based classroom type thing. It's not live, it's something that you can do on your own. So you just sign up for it and walk through it, and it has little quizzes and stuff. It's really good for when you're starting out. There are some advanced courses in there too that you can take, and that's all free. Also, can't forget to mention Swamp Up, which is coming up at the end of June. This is an opportunity to get your hands dirty with not just Artifactory, but other products as well. And all of the ticket prices are going to be donated, which is pretty awesome. That is a virtual event. And let's see what else. We do have a resource center as well that you can use. It has a bunch of webinars and white papers and things like that.
All right, and it looks like there's a few more questions. So Andrew's asking when or how and when would you expect the published component to be moved from dev to stage to release, etc. Repositories? Melissa?
I'm sorry, can you repeat that for me?
How and when would you expect a published component to be moved from dev to stage to release? What is that process?
So that you would definitely want to tie this into a CI/CD system, which Artifactory integrates with all of the major ones. We even have our own pipelines product that we've launched that would do this for you. It's a matter of some scripting, and then we also have JFrog CLI, which is also supported with all of the major CI/CD servers. So what you would do is you would set up a pipeline in one of these, and likely, if you can get through some quality gates like test pass, things like that, you can add metadata. And that metadata, you can use that to determine when to move artifacts. And there's also commands that you can give the CLI to automatically move the artifacts for you.
Okay, thanks. I think we've got time for one more from James. I'll direct this one to Dan. So what's the most compelling reason to migrate from Terraform to Pulumi? Dan, you want to take that?
Yeah, absolutely. Unsurprisingly, we get this question pretty often, and I think the major reason that you'd want to move from Terraform to Pulumi is if you're looking to really improve the experience and improve the collaboration between teams who are using infrastructure as code and who want to work together on cloud infrastructure. So if you have even just an individual or two on the team and they're working with developers on bringing cloud to their organization, there's a great reason to use Pulumi as kind of that lingua de franca, right? Common terms, common knowledge, and this also applies across teams, right? So there's that common common setup of dev, ops, security, and really one of the larger goals of Pulumi is to bring these groups together and have them talk on similar terms. And the second reason for this is the improved support across many different architectures. So Pulumi provides a really great experience in serverless. We have unparalleled experience in Kubernetes. We have great experience in virtualization and containers and ECS and Docker. Pulumi long-term and now are really going to be a great tool to be able to deploy those architectures and continue to evolve with your skill set and the architecture of your applications and the maturity of the team as you move on.
Great. Well, I think that's all we have time for today. I know there's a few more questions, so if folks want to go to slack.pulumi.com and ask any remaining questions they have in the workshops channel, or if you have trouble just getting started or need some help from the community, you can find relevant channels on Slack and ask your questions there. We'd be happy to help answer those for you. Thanks again for everyone for joining. Thanks to Melissa and Dan for their wonderful session that they put on. And we'll be sharing a recording of this video to everyone who attended in case you want to revisit the content. So thanks again. Bye.